In this video, we're going to solve LeetCode question 1457, pseudo-palindromic paths in a binary tree. So this is given a binary tree where no values are digits from 1 to 9. A path in the binary tree is said to be pseudo-palindromic if at least one permutation of the node values in the path is a palindrome. Return the number of pseudo-palindromic paths going from the root node to leaf nodes. Okay, so to start out with our approach here, one way to do this is by using a set to keep track of what numbers you've already encountered along a path. And the logic can go like this. So let's say you are starting out with the root node, which is 2. So your set, you begin with an empty set. Since your root node is 2, you add 2 to it. Now your root is 3, so we're just gonna go along the red path. 3 set. You can say, well, is 3 in the set? No, which is true. Then add it. Then you have another 3, and you ask the same question. Is root 3 in the set? Yes, it is. You've already encountered it. So then you actually remove the existing 3 in the set. So you're now back to 2. So by visual inspection, you can tell that this is a pseudo-palindromic path. You can form 3, 2, 3. So what we notice here is that the length of the set is 1, right? And so that is one case where you do encounter a pseudo-palindromic path. But let's take an example where you don't, like 2, 3, 1. So 2, 3. All right. So beginning from the 3 that is the left child of 2, let's just say you go right and you encounter 1. Then you ask, well, is 1 anywhere in the set? No, it's not. Then you add it to the set. So then at the end, you can see that length of the set is 3. I mean, and what's important is that it's greater than 1. So you return false. So this means it's not a pseudo-palindromic path, and we can use this logic to basically write out our code. So going back to, let's see. All right, so going back to our LeetCode. So we first do a check if root none, then just return 0. So at this point, let's pass this first because we need to work on a function that recursively performs a depth first search while applying the logic that we just discussed. So def let's just call it the def for search for short root. So I want the current the set to be represented by a variable called let's call it curt path, and then we're gonna add something to keep track of the total number of valid pseudo-palindromic paths. Let's just call it valid path count. So first we can do a check to see if the root is none. If it is, just return. Then let's see what the recursive calls may be. We can say, well, if root dot left exists, self TMS root dot left, and then per path, and then valid path count. If root dot right, self TMS root dot right per path. So here we want to make sure that we're actually like if a left node exists, we want to add it to the set, but we don't want to add it to the original set because the original set is a reference, and if you're recursively calling left and right with that same reference, you're gonna mess up your set. So what's best to do here is to make a copy and check if to apply the logic that we discussed. So if root.left.val is not in that set, that copied set, then just add it. Otherwise, we remove the value. We know that there is a value, is such a value currently in the set, and so we need to remove it. And here we just need to make sure that we are sending in the copied and modified set. And likewise, we perform a similar operation to the right. Make sure that we send in the copied and modified set. So before our recursive calls, we need to check if our current node is a leaf. So in order to do this, we just say if not root.left and not root.right. Right, and if it is a leaf, we'll just enter that if statement. And if length of per path, let's say it equals 1, And since we're gonna make valid path count an array of just one value, since we're gonna initialize valid path count with just like this. So we can say if not valid path count, or if valid path count is empty, append just 1 to it, else valid path count, increment that first element by 1. Right, and then after that, we could actually return, because we are at a leaf node, and we can start. So we can start completing our our main function up here. So remember, current path starts at the root. So we can actually initialize that set to the root value, and we can call DFS that we wrote on root count. Then we say, well, it is after valid path count has been modified by DFS, is it empty? All right, if it's not empty, return the first, the 0th element. If it is empty, just return 0. And let's give it a try. No, it's the wrong answer, huh? I'm just using one of the examples they gave. Seems like we're missing one case here. So, forgot to mention this. So, the fact that the current path has one element doesn't cover all the cases. The second case is, if you imagine starting from the root node of 2. If you keep going right along the green, and then imagine that it wasn't 2, 1, 1, it was just 2, 2, that 2, 2 is still a palindrome. So according to the logic that we were talking about, if the value, the second time we encounter a value and it's already in the set, we remove it, that means the set will be empty. So the other condition is if the set is empty. And I believe that will cover all the logic cases. Yeah, so that's accepted. Let's submit it and try. All right, so there you have it. Yep, pseudo-palindromic paths in a binary tree. All right.